Okay, welcome folks to a pop-up session of these weather and climate live streams. Guess I probably shouldn't call this an office hour because it was neither scheduled nor is it particularly academic. But in any case, welcome. This is a pretty significant morning in terms of California weather, and in particular Southern California weather especially. So one of the reasons I'm doing this is we have a high impact weather event that is just now, literally, as I'm speaking, starting to move into California's most populated region, the LA Basin. And there is a litany of significant weather conditions currently occurring or imminently going to occur in the LA Basin right during the morning commute, which always amplifies consequences down there. But there are some potential risks beyond just snarled traffic on the freeways, which of course is an inevitability, but it is going to be an interesting morning, let's just say. One of the most interesting pieces of what's going on right now is that for the first time in, I believe, 17 years, a severe thunderstorm watch has been issued by the Storm Prediction Center, NOAA's Storm Prediction Center, for specifically coastal Southern California, and yes, including the city of LA proper, as well as the rest of LA County. That should be an indicator this is pretty unusual, that there hasn't been a similar severe thunderstorm watch in 17 years in Southern California. And this is not because it is completely unprecedented to have severe thunderstorms or even a risk of an isolated tornado or two as there is today, but it's that this one was an event that really clearly had that potential in advance, and so the Storm Prediction Center, in coordination with the local weather office, so the LA, or Oxnard to be more correct, office in Southern California, decided that there was a pretty good chance of some very active thunderstorm activity, which we did see in the overnight hours and which appears again to be possible over the next couple of hours once again. These storms are now re-strengthening as they move right toward LA proper. And so there's a litany of things going on, as I mentioned. In addition to the severe thunderstorms, are the very heavy to torrential downpours that may well occur. This is not going to be a storm that brings epic amounts of cumulative rainfall. We're not talking about, multiple feet of rain in the mountains like you sometimes see with a strong wintertime atmospheric river. But the bigger problem with this one is that a lot of rain may fall in these relatively brief but extremely intense torrential downpours over the course of just 15 minutes, 30 minutes, or an hour. And that's the kind of precipitation that can cause flash flooding, and in particular debris flows, particularly in recently burned areas. And this is one of the major concerns this morning. And again, the main storm has not moved through yet in LA, so the worst is yet to come. It's still to your west, and I'll show you momentarily on radar. It's looking pretty intense out there as it moves east and is in fact re-strengthening as it moves toward the LA Basin this morning. So the most risky proposition with what remains of the storm is the considerable risk of significant flash flooding and debris flows, mainly in the recent wildfire burn areas of Southern California, specifically the Palisades Fire, the Eaton Fire, and also I believe the Bridge Fire, so a little bit earlier, that's autumn 2024 up in the mountains. Those are the three areas that are most at risk, but there is, with downpours of this magnitude, potential for some flooding even elsewhere. Not really river flooding, everything is too dry for that to begin with, but certainly street flooding, urban flooding, and flash flooding of small creeks and watersheds. So I would expect significant flash flooding, debris flow activity on the Pacific Coast Highway. For example, in fact, a flash flood warning has just, in the last few minutes, been issued. So there was, in the overnight hours as well, multiple flash flood warnings, numerous special marine warnings, essentially meaning that there's a potential for water spouts or strong winds in the offshore waters, but also at least one tornado warning for the Morro Bay area. Not sure if there was actually a tornado or not, but there were some damaging winds associated with that severe thunderstorm. The Storm Prediction Center originally issued the Severe Thunderstorm Watch late last night, just before midnight Central Time, until 6 a.m. local time in the LA area, but it has been extended now, and so it remains in effect. It was actually originally scheduled to expire at 6 a.m., but the main storm still has not moved through the LA Basin. It has slowed down a bit, which is actually means it may re-strengthen, as I mentioned, before moving through the LA Basin, and so the Severe Thunderstorm Watch was extended Right now it's been extended through 9 a.m. local time, so for the next 40 minutes still. It may or may not be extended beyond that, but even if it is not, there will be a potential for some severe thunderstorms, flash flooding, and even a tornado or two throughout at least the rest of the morning in Southern California, whether or not that watch is extended. So, again, thanks for joining. I know we're probably going to have a lot of people on today. This often happens when major weather is moving through the Southern California metros. So thanks for staying on topic in the comments. Looks good so far. So thanks for keeping it there. And I will periodically be returning to the comments to look at the questions as they come in live. So first, what I want to do is go over, share my screen, show some radar, because it's an interesting day out there already. And so I'm going to turn on my radar screen drawing tool, which is different from my normal screen drawing tool. Always a fun little thing to get right there. Okay, so what do we have right now? In some ways, this radar imagery at this moment doesn't look quite as impressive as it did late last night near Morro Bay, but again, that could change pretty quickly, and I actually expect that it will as this squall line, sort of here's the leading edge of the squall line, moves into LA County. It's just entered western LA County. It's about to move through Malibu, and as you can see, there is a flash flood warning that was just issued recently for the Palisades burn area, so all the way to the Pacific Coast Highway and the Pacific Ocean for the entire burn area. So it includes eastern Malibu, Topanga Canyon, and then all the way into the western fringe of Santa Monica. Even ahead of that squall line, if you zoom in a little bit, you can see that there has already been occasional heavy downpours falling in the burn area, and that is before this intense squall line moves through. You can see that this squall line actually doesn't look quite as impressive out over the open ocean, but once it's moving inland, it's actually intensifying. So up by Thousand Oaks, up into Oak Park, so again, far western LA County. This is a pretty torrential downpour right now, and this is about to move through the Palisades burn area. So debris flows along the Pacific Coast Highway, which I believe is closed potentially to regular traffic right now, and many homes have been re-evacuated here, is imminent. So I would expect there to be debris flows along the Pacific Coast Highway downhill of the Palisades fire in the next 30 minutes if there haven't been already from these more isolated downpours. Also, you can kind of see that this line is strengthening as it moves inland. This is something we often see in these situations where what's going on offshore doesn't fully tell you what's going to happen when it makes landfall because of frictional convergence and the uplift of the coastal hills. I'll talk a little bit more about that later. The other thing that's going on is there's also a severe thunderstorm warning issued. That's this yellow box here for western LA County. I think that's just technically western LA County. Not sure if it's a little bit of Ventura, but really this is mostly from about Santa Monica west to the western end of the county. Would not be entirely surprised if a new warning was issued more for central LA in the next 30 to 60 minutes. This is, I believe, probably going to be mainly for strong gusty winds. That's right. So, but also for the potential for an isolated brief tornadic or waterspout spin-up. So 60-mile-an-hour wind gusts are possible along with an isolated brief tornado. Right now, if I pull up the imagery that would show me the risk of an imminent tornado, I don't see anything right at this moment, although again, that could quickly change, and I would not even be too surprised if it did. Here on the left is, whoops, that's not what I didn't want to jiggle it around. This on the left here, in this oval, you can see the precipitation echoes, and then on the right here, what you can see is the wind associated with those echoes, and then essentially reds versus greens. Again, I apologize for the lack of colorblind friendly scales here, but essentially if you see a red and a green in close proximity, that means that there is some rotation. That means that there is some movement in the precipitation echoes toward the radar in one color and then away from the radar in the other color, so red and green respectively. And that means if they're occurring in close proximity, it means that there's something rotating. And there's nothing too dramatic on the radar right now with rotation, although I actually see a couple of little pockets. This is not indicative of a tornado by any means, but it does suggest that there are elements of the squall line, some weak couplets where some things may be rotating a little bit. None of these indicators no tornado, but I think the most widespread problem with this is going to be torrential downpours and potentially some street flooding widespread when it moves over your head, and then maybe some more serious flash flooding debris flows in the burn areas. The other thing that is interesting that I can show here, and I'll talk about this off in a minute, the Severe Thunderstorm Watch, as I mentioned, from the Storm Prediction Center, first one in 17 years for this part of Southern California, that's this region here. So it previously extended over more of the central coast. Obviously that has moved, the storms have moved to the east now, so the remainder of the extended watch is now squarely over, essentially it's LA County. Maybe a little bit of adjacent counties in the coastal waters, but this is mainly focused right where a significant chunk of California's population lives. So it's a small watch, but it's affecting millions of people. And this severe thunderstorm warning currently is affecting just the western fringe of LA. But again, I would not be too surprised if this ends up being extended eastward. Not seeing too much lightning, which is a little bit ironic for these severe thunderstorm watches. This sometimes happens in California with these low-topped supercells or low-top thunderstorms where they don't always get tall enough to produce cloud-to-ground lightning. Even though they walk like a thunderstorm, they talk like a thunderstorm, they can produce tornadoes and strong winds and flash floods, and they may not produce lightning. That, again, could change. This could start producing visible lightning at any moment, although it doesn't look like it is right now. If we go to the west, though, if we go to Vandenberg Air Force Base, we actually do see that there are storms that have been producing actual definitive lightning. So you can see the strikes that were out here. And also, these, although we're behind the cold front here, and the Severe Thunderstorm Watch is mostly to the east, there's still a possibility of an isolated severe thunderstorm or brief tornadic spin-up with these cells as they move east and inland along the central coast. So severe threat, not over yet for Santa Barbara County. Even though the front has moved east, these more isolated cells could nonetheless produce that kind of isolated tornadic event or isolated flash flood. These are still really torrential downpours here. So main interest is LA County at the moment, but Central Coast still could see an interesting day. And also, even after the main front moves through LA, and now going back to the LA radar here, there will still be at least a slight chance of some isolated severe thunderstorms later in the day from that post-frontal activity. Just watching this squall line, as I mentioned, it's intensifying as it gets closer to the coast. Look at what's this segment just off the coast of Malibu, now moving through Malibu, now officially moving into the Palisades burn area. If I pull up the satellite map here, this is a pretty impressive October storm. Probably doesn't take too much effort to guess. That is not what I intended to do there, sorry. Getting used to some new keyboard shortcuts. There we go. Guess where the low pressure system is. Well, there it is in the classic position where you sometimes see significant severe weather in Southern California. So also guess where the cold front is. It's essentially moving into LA County right now. So this is the cold front, more or less, and I'll draw that on the map here. There's the low pressure system. It's actually sunny over parts of the Bay Area right now, although some scattered showers and isolated thunderstorms will probably redevelop later in an unstable atmosphere. But what you can see is all this cold air diving southward. This is cold and relatively dry air. Ahead of this system, we actually have moist and pretty warm air. In fact, there's even some residual moist air from the tropical storm, the remnants still. You can see that over Arizona, but there's a little bit of it even in Southern California still. And the other thing we've got right now is we have, so I'm going to clear this. So essentially we have this low pressure system centered near Monterey Bay, maybe a little bit south. We also have what's known as a strong jet streak. Not just a jet stream, but a jet streak. And this is essentially a region of accelerated upper level wind flow beyond what you would normally experience, and also it's stronger here than it is elsewhere. And what this means is that we have some extra upper atmospheric lift. So when you have this jet streak and you're on what's known as the cyclonically curved side of it, which is essentially in the northern hemisphere the left side of a jet like this, it allows for upper level diffluence and sometimes divergence, meaning, so I'm going to draw something in plan view here, or actually this is plan view, excuse me. I'm going to draw something as a vertical cross-section. So when you have upward motion in the atmosphere, and let's draw this, I'm just using this as a drawing template. Let's just say that this is, let's just call this height in the vertical direction. So going upward is higher in the atmosphere. That makes sense. You have air that is rising in the atmosphere, and generally you have to then have convergence of air near the surface, because if the air is rising vertically away from the surface, it creates a little bit of a vacuum, a low pressure, if you will, and the earth is not going to, the solid earth is not going to rise up and bulge up to fill the void, so air has to rush in from the sides. That's why when we have this low pressure system here, we have essentially some inrushing air into the center of the low pressure system near the surface. And that's why you tend to see clouds and storminess near the center of a low pressure system. But in the case of a jet streak, which is what we've got here, so think of these high level, upper level winds blowing like this. When you are on this side of it, what you end up having is the potential for some lift in the atmosphere, because what you actually have is at upper levels, you have divergence. So instead of convergence near the surface, here, surface low, you actually have air moving outward at the top, which is actually what you need to sustain this low pressure system. So you need the inrushing air near the surface and the outrushing air at the top. Now, you can have a pretty strong low pressure system that does a lot of work on its own, even if you only have what's going on here at the bottom. But you can also have, you can augment it, supplement it, amplify it by also giving it ventilation at the top. So essentially what you've got now is, because you have this low pressure system and this jet streak here, what you've got is pretty robust upward movement in the atmosphere. This is the opposite of California's typical stable marine layer situation, where you just have a nice solid lid on things. Here you have inducement of vertical upward motion, both by what's going on at the surface, and it's also being reinforced by what's going on aloft. So call this the jet streak and call this the low pressure at the surface. So what you end up getting is a circulation that looks like this. And that's exactly what you need for those tall clouds that become thunderstorms. The other thing that's going on is we have, as I mentioned, we have unstable air near the surface, meaning it is warm and moist, so relatively buoyant. It wants to rise if something gives it a kick. Well, something like the upward motion from the jet streak, for example, which is what's happening. But you also, for severe thunderstorms, the key is that you can't just have, and I'm going to draw my nifty thunderstorm again. Here's the cumulonimbus cloud with the anvil and my stylized lightning bolt with some rain. What you need is you need upward motion in the updraft of the cloud to build the cloud in the first place. That much I think is fairly intuitive, and then you have some outflow near the top since the air hits the tropopause and spreads out. But if you have air that rises and then falls in exactly the same place, then the storm is going to extinguish itself. It's not really going to persist, because you have an updraft and then you have a downdraft that kind of just extinguishes the updraft, and they essentially cancel each other out. That's why you get pulse thunderstorms. They pulse up and then they sort of fade away. So pop-up popcorn showers and thunderstorms, ordinary. However, if you have what is known as vertical wind shear, so if your thunderstorm cloud now develops a bit of a tilt, if it leans over a bit like that, now what you've got going is you have an updraft that is angled a little bit. It's not perfectly upright, but more importantly, the downdraft is occurring somewhere else. In this case, it might be occurring, say over here instead, relative to this storm. So again, here's our lightning storm. Here's our thunderstorm. Now what you've got, because you have vertical wind shear. So imagine as you go upward in the atmosphere, the wind is getting stronger and tilting the storm so that the updraft is not in the same place as the downdraft. Now what you've essentially got is a storm that can become self-sustaining, because it can have upward motion here, and there's still what goes up must come down, but it's happening somewhere else. And so you can continue to get this sustained upward motion in the atmosphere without things falling apart. That's Severe Thunderstorm 101. That's why there's a Severe Thunderstorm Watch in effect for this part of Southern California, because we have those conditions right now. And a couple of folks yesterday asked if I could bring up that paper that was mentioned by the Weather Service. And so here I did dig it up. This is the Hales et al. Paper. I believe this is from 1985. So this is a much older paper but fortunately it's been digitized by the Weather Service. This was essentially a paper focused on the synoptic features. Whoops, that's the wrong. Well, I guess you get a free radar view again. That severe thunderstorm warning continues with that downpour now moving right through the Palisades burn area. But what I really wanted to show again is here again. I'm just getting used to these keyboard shortcuts. There we go. So synoptic features associated with Los Angeles tornado occurrences. This was recognized back in the 1980s after a significant outbreak in November, which is a bit of a familiar time, 9th of November, about 3 weeks from now on the calendar. So this is not necessarily an unexpected time of year to see this. But following that, there was more widespread recognition that California actually had perhaps more tornado risk than folks had realized. We don't get the same kind of really intense, devastating tornado outbreaks that the central U.S. get. We simply don't have the same atmospheric conditions that are required for those. But on the other hand, there are some pockets of California that see fairly regular, weaker tornado activity. And this map, although this map is now essentially 40 years old in the mid-'80s, it's still largely correct. There are essentially 2 or 3 mini tornado alleys in California. So one of them is in the Central Valley. In particular, there's a cluster near the north end of the valley, a cluster near Sacramento, and then a cluster near Fresno within this broader window. There is the high desert cluster. Some of these tornadoes probably go unreported, so there are more maybe than are indicated on this map. But the most dense mini tornado alley in California is right near the LA area. And although sometimes we say, is that just because there are millions of people there, and so every time there's a tornado it gets reported? Well, there might be a little bit to that, but there does appear to be something meteorologically special about the LA Basin that does lead to at least occasional actual outbreaks of tornadoes to a greater extent than is true elsewhere, and that remains true today. The conclusion of this paper essentially, here is the sort of the canonical or the typical meteorological setup that was recognized in the 80s regarding tornado outbreaks in Southern California. And again, essentially it's saying there's got to be a low pressure system somewhere here, which check, we just showed that on satellite. A cold front moving through like this. Well, this is a little bit farther east. Currently it's here, but it'll be there soon. And a jet streak just like this, which is exactly what we've got right now. So essentially we check the box for the analogs in this paper. That's why we're seeing what we're seeing right now. We go a little bit further down. Again, we can kind of see, I mean, look at that satellite image. This is from 1982. It's not quite as robust as that storm, but it's notably, strikingly similar. But the conclusions of this paper, that it's always nice to jump to the conclusions when you're short on time. So just to highlight that, I'll circle them here. But essentially, that LA area tornadoes occur during the cool months, of course, from September through May. So we're check that box. Center of cyclonic wind circulation, essentially meaning a low pressure system from the surface all the way up to 500 millibars, essentially saying there's a low pressure all the way from the lowest level of the atmosphere to the half mass layer, located in an offshore area to the northwest of Los Angeles. So we check that box. Increasing winds with height to speeds in excess of 50 meters per second, with the strongest winds south of Los Angeles. Again, I'll show you that in a moment, but we do check that box. Surface frontal or post-frontal confluence zone in the area. We've checked both of those. As I mentioned, some of the storms today may actually come behind the front. Moist onshore low-level flow with dry air aloft. Again, I'll show you that box is checked, and a surface lifted index less than 0, meaning essentially the atmosphere is sufficiently unstable with sufficiently strong lapse rates. We check all those boxes. I'll show you in a moment why we check a few of the other ones. But the last point here is that there is one of the reasons why there does appear to be a local maximum is due to surface frictional convergence along the coast. And I'll bring up the radar map to show you, this is again live now, what is meant by that. And I think you can actually see this happening right now live. So again, I'm going to emphasize the approximate coastline. of California in this region with the blue here. Now you can see that there's wind blowing. Essentially, the movement of the precipitation in the individual storm cells is essentially perpendicular to the coast here. And again, keep in mind that there are the Santa Monica Mountains here, roughly parallel to the coast, and you also have the higher transverse mountain ranges further inland, the higher mountains. So I'll draw poorly these mountains and then these lower mountains along here. So what happens when the surface area is forced to go inland? Well, the ocean is relatively smooth. There are waves, but what's the largest wave in the ocean? 20, 30 feet or something like that on a bad day. The mountains, even the lower ones, are already a couple thousand feet tall, and then you go inland, and then this round of mountains is thousands of feet tall. So the low-level air, due to those mountains, and even just the surface roughness of there being trees and chaparral and brush and buildings and all of that, is forced to slow down because it's blowing over smooth waters. It's got a certain speed, and then that free-flowing air hits surface barriers. So there's friction. That frictional process slows the wind at the surface, but it doesn't slow the winds offshore. So what it means, essentially, is that you've got winds offshore that are very strong, as represented by this long arrow, and then as you get onto the coast, represented by the shorter arrow, these winds weaken as they go inland because the friction forces them to slow down. But what this means is that the air is piling up along the coast because you're still getting that flow offshore, but you're not allowing the air to move inland as quickly as it's accumulating at the coast. So you have convergence right along the coast in this region. And look what happens. Right offshore, so essentially convergence, again, at the surface means, again, thinking in the vertical view, in the vertical space, if you have convergence near the surface, that forces air to rise. That's what's happening right here, or over the LA Basin later. And the net effect of it is that you get precipitation or potentially thunderstorms that intensify right as they hit the coast because of that frictional convergence, and also separately uplift by the coastal mountains. Just for newcomers, reminding that there is currently a flash flood warning in effect for the Palisades burn area, and also a severe thunderstorm warning in effect for western LA County. And we can see that there is a very heavy rain band moving right through the burn area right now, getting ready to move into more central parts of LA imminently. I'll double check again, not seeing any imminent signs of rotation or waterspouts or tornadoes, but it remains possible with the rare, first in 17 years, Severe Thunderstorm Watch in effect for Southern California currently. Okay, so I'm going to switch back. You're going to see me. I'm going to answer some questions since I haven't done that yet. Take a quick sip of water here. A lot of folks in Southern California tuning in, which is not surprising given the significant weather. And again, LA proper, the storm will get more intense before it's over. It hasn't really arrived yet in its entirety. Comment that mid-Wilshire, the sun is almost peeking through, which actually means for now that the instability is increasing. That means it's making the atmosphere even warmer and therefore more unstable than it would have been. This is why I think that this line of storms may intensify right as it moves to the LA Basin, because there are sunny breaks right ahead of this cold frontal convergence zone where the instability is maximized. Violet mentions waiting down here in San Diego. Might not be as impressive that far south, but yes, it's definitely going to be later before it gets there. Similar question from the next commenter about San Diego. Cynthia mentions here at the Eaton Fire burn scar in Altadena, stay safe out there. There could be significant flash flooding. Obviously, you have a better sense of where you are relative to the drainages and the creeks and the previous debris flow basins. Wet in Ventura. Yep, that's not too surprising. That cold front has either moved through right now. Little rain so far in the Inland Empire, which again is not super surprising. Eric mentions that some parts of LA County already have seen 1 to 3 inches of rain from these prefrontal downpours, and so again, that does prime the system for more flood risk as the final heavy downpour moves through, which will be the most intense part of the storm, is yet to come in most spots. 1.2 inches in Thousand Oaks, that's pretty respectable for October. The good news is it's fire season ending or rain in Northern California, or at least fire season mitigating rain in Southern California. Chilly in San Diego this morning. I guess that's all relative. Interestingly, it's pretty mild across the LA Basin where the sun is breaking through. Up in the mountains, a report of 2.7 inches so far, so that's consistent with what other folks have been saying for the region. Comment from sound in and out, audio cutting out. Let me see. I know this is a little bit old. I don't know why that is. I actually haven't had any connection issues this morning, so I don't think that's a connection issue on my end. A lot of folks mentioning they're having audio issues. I don't know what to think about that one. Let me know if it continues. But it does seem like the solution is that people kind of restart the stream on their end, and it seems to resolve itself. I really don't know what that is because, at least as far as I can tell, I have not had any connection issues. I just checked the stream health, and it's been perfect throughout the stream so far. Okay, a lot of people with the audio. Okay, I'll have to troubleshoot that later. That might actually be a YouTube problem. But most other folks saying that the restart works, so just literally refresh your browser if you're having that problem. Report from SM Mountains. I'm guessing that could be Santa Monica Mountains. 1 3/4 inches already and half an inch in the last 20 minutes. So I'm guessing that is Santa Monica Mountains because that squall line is moving through right now. So a couple of comments about the Elsinore convergence zone. That's another, that's sort of, it's an even more localized place where there are occasionally tornadoes in California. There are a couple of isolated pockets like that. I almost might consider that to be similar to the Inland Empire Desert one. Similar patterns kind of tend to produce them. I'll go back to showing live radar and satellite in just a minute. Question, what interactions do the Channel Islands have as the system moves ashore? We often see the eddies in the lower level cloud layers. Are they inflated? Yeah, they definitely factor into the weather on days like today. As I mentioned, the islands, especially the Channel Islands that have higher topography, some of them have significant hills on them. They can disrupt the surface level flow, so the wind has to sort of part as it goes around the islands, and then it sort of reconverges on the lee side, so on the downwind side, and that can result in essentially amplification of showers and thunderstorms, and even the potential for water spouts in a day like today on the lee side of the islands as those converging winds rejoin stream flow or the streamlines. So a day like today, that would be on the northern or eastern side of the islands. And sometimes that can have effects all the way to the coastline because those convergence zones can be kind of persistent on a day like today when there's other processes that reinforce them. Yeah, folks pointing out that perhaps the the audio issues are due to the storm. That is actually possible in some parts of Southern California. I am hearing about there is some disruption to the telecommunications infrastructure. This is not that uncommon when there's heavy downpours, by the way, in Southern California. It's perceived as not a place where it rains very often, and sometimes there are literally gaps in cables where things get wet and there is electrical interference that shouldn't be on those cable lines. So tisk to the utilities here. But it does seem like for most folks restarting fixes any audio issues, by the way. Okay, so I'm going to pull the radar back up and then maybe show some weather model data, because there is, as I mentioned, quite a lot of interesting stuff going on. So let's first reshare my screen. I'm going to turn off this watch box as it's a little distracting. I'm going to zoom out a little bit. There we go. So folks in the Santa Monica Mountains who were reporting that really heavy rainfall in the last, that's this line as it's come through. Again, this is heading right for, if you're on the 405, get ready. This is just a couple minutes away from hitting the 405 corridor, and it's almost parallel with the 405 corridor, so it's going to hit pretty much the whole freeway segment all at once. So that's always another case for a traffic nightmare. But also, again, this has now moved through the Palisades burn area, so I would not be surprised if there are active debris flows right now along the Pacific Coast Highway here, and maybe some street flooding issues inland. You can continue to see that this line keeps intensifying right as it hits the beach and moves inland, so it's more impressive than the offshore reflectivity would suggest. Zooming out a bit, we see some prefrontal rain developing over Orange and eastern LA County. This is probably the steady, moderate, or even locally heavy rain across the San Bernardino and San Gregorio Mountains. Part of the problem with this is it preconditions the watersheds to then respond pretty quickly when this really heavy downpour moves through in about an hour. So for Altadena, Eaton Fire, that risk of a significant debris flow or flash flood will probably come in the next hour associated with this band, or slightly lesser chance with something later today way behind the front with a more isolated but very intense downpour. Again, you can kind of see the clear slot here. This is where people are showing sunny skies. This is one of the reasons why I think there's some surface-based destabilization of the air mass in this region, and perhaps why this line may well intensify as it moves inland. And then you can also see a broader region of lighter rain behind this intense band. This will bring more gentle rain. This is probably not going to cause any problems in itself. But then the challenge will be later today. Behind even that, there is yet one more feature of interest, which is the post-frontal thunderstorms, showers and thunderstorms, and these are looking relatively heavy duty along the central coast. Each of these has a little bit of rotation, as you can see on this map on the right here, with the red and green pairings. Again, nothing too strong right now, but all of these are rotating at least a little bit, and they might begin to rotate a bit more again as they move toward the LA Basin. Rotating cells means stronger ones and the chance of an isolated waterspout or tornado. So also these, although they're more isolated than the main rain band, each of these has very heavy downpours in them and could produce localized flash flooding once again in the debris flow, in the wildfire burn areas as they move eastward later today. So I'll go back and keep it on the LA radar because, again, this is the one with the most activity. We've seen worse, so it's not the worst thing we've ever seen right now, but it's a high impact event. A lot of people live here. This is moving right through the most densely populated part of LA imminently. It's about to hit the 405 corridor. It may yet intensify further. Why am I saying that it may intensify further? Well, one of the reasons is if we look right now, this is, actually let me update this to the most recent model cycle. Right now, this is what we got. We have some really moist air. So the dew point is in 60 to 62 degrees in the prefrontal. So essentially what we've got is, I'm going to draw on my screen again here. We've got a cold front that's about right here. And ahead of the cold front, this blue area is really moist air at the surface. So dew point in central LA is about 58, but in the offshore waters, it's in the low 60s. That is juicy air. In fact, you can see that there's actually this region of moisture air right ahead of the front that is moister even than it is in San Diego and Oceanside. So again, these units are in degrees Fahrenheit, but this is actually a measure of moisture. This is the dew point, which is measured in temperature units because it's a measure of the temperature at which dew forms, but it is in effect a measure of absolute humidity. Now, if I add the winds onto this, so you can see this is the same map but with winds added. When you see a wind barb, by the way, when the wind, this is called a wind barb, when it looks like this means that the wind is blowing, they point in the direction to which the wind is blowing. So that means the wind is blowing from south to north. This means it's blowing, these two bars mean at about 20 knots or 22, 23 miles an hour because each long bar is worth 10 knots, each short bar is worth 5 knots, and if you ever see a triangle, that's 50 knots. And so essentially you add, so if you were to see, and I'll clear this away, if you were to see this, for example, on a wind barb, and you saw a triangle and two lines like this, that's 50 plus 10 plus 10. So that's 50, 60, 70 knots. This would be hurricane force winds out of the southwest, again pointing in this direction. Now, fortunately, no hurricane force winds near ground level. That would be a much worse storm. What we do see in Southern California is look at all of these, the wind barbs in this region, in the moist blue region. There is pretty significant, so you see a lot of 20s, so 20 to 25 mile an hour winds. Here, there's more like 30 mile an hour winds along the front. That's moving really moist surface air and forcing it right up against the coastal mountains. And again, dew points in the 60s, that's pretty juicy. That's a humid air mass for California. Okay, so what else is interesting? What is the temperature right now? I know folks in San Diego are saying it's chilly, but it's still 65 degrees, so I think in other parts of California that wouldn't necessarily qualify as chilly. But I will say that you can see the cold front. Sometimes the cold front's a little indistinct. Look at that line. I'm just drawing the cold front based on where the separation in temperature is offshore. You can just see that there's a pretty clear demarcation of warmer air versus cooler air behind it. It's not super dramatic. It's 58 degrees in LA, 55 degrees in Oxnard, and 52 in Santa Maria. So maybe a difference of 5 or 6 degrees along and behind the front, but that's enough from a California perspective. And look, offshore here, the water temperatures are close to 70 degrees, which is close to what the water temperature is. So the difference between 70 here and 55 here is more significant. That's more like a 15 degree difference, and that's substantial. So take a look at the lightning flash density predictions. Again, this is showing that there is some higher likelihood for some thunderstorms along the central coast, as I mentioned, in the next couple hours, maybe even the southern Sierra foothills too. But see this band moving through western LA County. Maybe not the most impressive at the moment, but there is some lightning potential associated with it. And this is suggesting it, again, may intensify as it moves across the LA Basin. This is a forecast model. Again, going later this morning, the lightning risk will wax and wane. Not quite sure this is a fully representative of the lightning later in the day. But what I really wanted to show here was, let's see here. So if I go back to the present here, again, we have these, remember how I mentioned that severe thunderstorms, you need winds coming from different directions and increasing in strength as you go up. Well, that's exactly what we have here and right along the front near LA. So we've got Again, remember how I mentioned hurricane force winds were a triangle and 2 bars? Well, look at the black one here. It's maybe a little bit hard to tell on some screens, but if you focus just on the area in the circle, the red barbs are the ones closest to the surface. So that's saying there's winds out of the southeast at about 20 knots, 20 miles an hour or so. Okay, that's substantial. It's a stiff breeze, but nothing too destructive. But then you go up and you see that winds a little bit higher up get stronger. So there's 3 bars and then 1. So that's actually 35 mile an hour winds, a little bit higher in the atmosphere, and also veering to the southwest. So there's a difference in the angle of the winds. And then the black barbs, you go up even higher. That's a hurricane force wind up at 500 millibars. So that's halfway up in the atmosphere. That's 75 to 80 mile an hour winds. So we're checking those boxes. We have winds that are veering from the southeast at the surface to southwest aloft, almost a 90-degree difference. If I blow this up, you have winds blowing at higher elevations from the southwest, at lower elevations from the southeast, and they get stronger the higher you go. That means that essentially you have both the vertical speed shear, so winds get stronger as you go up, which helps those thunderstorm updrafts tilt. Remember, we need that tilt of the updraft to keep it sustained over time. And it also means that those winds are strengthening as they go up and changing direction. It means that there is warm, moist air near the surface moving to the front and cooler, drier air aloft. And that combination of warm, moist near the surface and cool, dry aloft makes the air inherently unstable and predisposed to heavy downpours and thunderstorms. Surface-based CAPE, not incredibly impressive. It's in the 300 to 500 range, but again, that's enough in this part of the world. This wouldn't be enough in the Midwest. This would be a very boring day in the Midwest, but around here, that can do it. And these are photographs, essentially showing the curvature of the air as you go up. I won't get into this too much. But there is, in the very lowest level of the atmosphere, what you want to see if you're going to get a tornado, what you want to see essentially is curvature. So essentially, photographs are showing the pinks are the lower atmosphere, the red is the middle atmosphere, the green and the yellow is the upper atmosphere. Essentially, it's saying what is the direction of the wind as you ascend. So if I'm going to draw this down here, essentially what it's saying is winds are coming out of the southeast, now they're coming out of the south as you go up, and now they're coming out of the southwest as you go up to higher elevations. This is what you want to see for a tornado. You want to see this kind of curvature as you go up, because it's saying that at the surface you have those southeasterly winds, and at upper altitudes you have those southwesterly winds. And that is in fact exactly what we have in the photograph that's closest to LA right now. It's only in the very lowest levels, but these are low top supercells, as that paper showed, and that's exactly the kind of pattern that you'd expect to see. So again, not the most extreme severe convective setup in the world, but at least until the front moves through, conditions are favorable for brief tornadic spin-ups in LA and Orange counties potentially. Again, the big picture, or at least the medium big picture, is we've got this highly anomalous autumn low pressure system right near the California coast. It's moving southeastward. Or I guess I should say it's moving maybe eastward now. This is going to stick around through tomorrow and continue to bring significant weather to coastal Southern California all day today. Wraparound is bringing heavy Sierra snow, so this is a big snow day. And then isolated showers and thunderstorms in the Bay Area, still likely later today. I was talking earlier about that jet streak, and I'll just show you what I mean by that. If I show the 250 millibar winds, here we go, especially as I go later in the day. Here is that jet streak. The jet stream in general is this whole thing, but the jet streak, and I'm going to use a different color here because this is a little bit hard to see. I'm going to choose hot pink here for contrast. The jet streak I'm talking about is here, because if you look here versus here, and notice that the jet stream is weak here and strong here. So this is a streak as it strengthens here. The jet streaks within the jet stream, bit of a tongue twister, are favorable regions for upward vertical motion in the atmosphere, especially when you're on the cyclonically curved side of it. essentially meaning cyclonically curved means on this side. So the wind speeds are really strong here, but they get weaker as you go left. And that means if the wind on this side of the jet is going to turn, if you are to go perpendicular to the flow, it means that first you're going, well, sorry, that's probably a little bit beyond the technical discussion that I want to have today, but trust me on this one. This is a jet streak, and we have this upward vertical motion, as I described earlier, in the atmosphere being induced by it, which is reinforcing the upward vertical motion from what's going on in the lower atmosphere, but it's the top down and the bottom up both causing that upward motion here. Okay, so I'm going to go back and take a look at the radar once again, what's going on in LA. So, yep, now we're along the 405, particularly the northern part of the 405 corridor up by San Fernando, in the San Fernando Valley. Heavy downpours, not looking too crazy at the moment on the southern part of the 405 corridor into south central LA, but that again may change because this is the main feature of interest and it's still moving toward the coast here. If I zoom in on satellite to the LA region, these are those sunny breaks that people were talking about in the LA area. Right around here, you can see here is the cold front, obviously, and so the more sunny breaks you get ahead of it, the more destabilized the atmosphere gets. And you can see behind the front, there's also some partly cloudy skies with sunny breaks leading to more atmospheric instability. So again, this is the main feature of interest here in Southern California at the moment. Okay, so I'm going to bring back my face on screen. You're going to see me. I'm going to answer some more questions.
All right, so I'm still here. You're not missing the sound. I'm just taking a little bit of a mini 15-second break from my voice as I read the comments here. Any chances for lightning in Ventura County? David asks. Yes, there could be some through the early afternoon. So you're now behind the front, but there actually is more lightning behind the front than before it right now. Marley mentions pretty wild flooding in San Jose last night. I'm guessing this was in the evening associated with that narrow cold frontal rain band. There was a significant amount of urban flooding in the Bay Area. None of the rivers, of course. It's just too early in the season. The conditions are too dry for that. But there has been a significant amount of urban flooding. This has been a fairly, let's call it dramatic storm as it moves through. Mary mentions there's currently 4 different ICANs for traffic crashes along a 1-mile stretch of the 405 where the rain is. Yeah, that's all I gotta say about that. Yeah, that's LA driving for you. Question whether LAX is landing from over the ocean because of unstable winds over land. So unstable in this context doesn't actually mean the winds are changing quickly. They're actually quite steady in LA, so it's actually easier to plan for a landing when those winds are steady out of one direction. Unstable means in a vertical sense that the atmosphere is prone to upward vertical motion. So what it might mean is you have an unusually bumpy descent or ascent to or from LA on a plane because there's thermals and turbulence. Your plane's going to shake as you fly in and out of individual updrafts. In fact, a larger plane, if you're on like a 787 or a 777 or something like that, or a A380, the plane is large enough that the left tip of the left wing and the right tip of the right wing can be in completely different updraft conditions. This is essentially what turbulence is. And it's actually one of the reasons why you often experience less noticeable turbulence on larger aircraft, because you're averaging over a wider distance and you're less likely to have a strong differential between one wing and the other. As one small wing flies through an updraft, a strong one, that side of the plane gets pushed up, or if the front of the plane is in an updraft and the back of the plane is not. Remember, updrafts are not necessarily very big. The thermals in the atmosphere can be about the size of a large aircraft in some cases, and so as you can fly completely through and then completely out of one in a couple of seconds. That's what's going on when your plane feels like it's pitching and rolling. Sometimes it's really only 20 or 30 or 40 foot little drops, but you really feel it because, of course, how big are we? The tallest of us are generally under 7 feet, and so 20 or 30 foot pitch or a change in the angle is quite noticeable. Long story short, I actually don't know the flight path at LAX and which direction the current traffic flow is. Usually with aircraft, you essentially you want to take off in a direction that is either you'd rather fly into the wind when you're taking off because, of course, flying into the wind helps you lift off a little bit. What's challenging is crosswind, either from landing or takeoff. So if there's a large component of the wind that is perpendicular to the runway, that's tricky because it kind of wants to push your plane immediately off the runway, either as you're taking off or landing, and you don't want that. That's something that pilots have to actively counteract. So if you've ever seen a plane land at an angle that looks like it's misaligned with the runway, that's typically because you're trying to anticipate the component of the wind force that's going to try and push you off the runway, and you're trying to counteract that. Those are difficult landings or takeoffs, and it's usually there's a little more tolerance for landing in such conditions because you got to get on the ground at some point. Takeoffs, though, it can really interrupt traffic flow because those are a little more optional. You can always wait, and so the direction of flow sometimes reverses. Again, I don't know LAX traffic patterns specifically, but they can, at least at many airports, depending on the direction of the wind, the typical direction of takeoff can be reversed if the winds are out of an unusual direction to, again, prevent wind shear or to make sure that you're taking off at an angle that makes sense relative to whatever direction the wind is coming from. So there could be some delays at LAX today, not so much because of the instability, but more just because of the active weather in general, and expect it to be bumpy. There's a good question from Jose Gallardo. Why is there no lightning, even in impressive-looking storms, while unimpressive high-level clouds can produce dry lightning? This is a profound question, because often think about those high-base thunderstorms in summer or fall that produce those like tens of thousands of lightning strikes, like what we saw earlier in September in different parts of the state, versus what we're seeing now, which is an objectively impressive system, as I mentioned, with plenty of ingredients all the way from the surface to tens of thousands of feet up in the atmosphere for vertical cloud development. What's interesting is a lot of those high-base thunderstorms we see, they're actually not as impressive of clouds. As Jose mentions, they're shallower clouds. They might have a base at 10,000 feet and they might rise to 20,000 feet. So they might only be 10,000 feet tall. In any other part of the world, that's not tall enough to produce lightning. That's too shallow of a cloud for thunderstorms. But due to the specific cloud microphysical characteristics, under the conditions that we see elevated convection, it can nonetheless be enough to generate lightning strikes because there is adequate charge separation between the top of the cloud and the bottom of the cloud, or the top of the cloud and the surface of the Earth, producing lightning. It's that charge separation that produces lightning. We still don't have a great scientific handle on exactly what causes lightning to have certain characteristics in some clouds versus another. It's also not my area of expertise, ongoing area of science, so it's actually not something that's fully resolved. But we do know that lightning essentially results from charge separation, and that there are certain conditions including the presence of large amounts of ice crystals in the upper cloud that favor the development of charge separation that then leads to lightning. What's interesting, I think part of what's going on here, is that when you have elevated storms, they're shallow clouds. They're only maybe 10,000, 15,000 feet tall, between 10 and 20 or 10 and 25,000 feet. But they're high in the atmosphere. So you see how they have what are known as glaciated tops. Essentially, they are icy. They're ice crystal clouds. Even if they occur in the middle of summer, when you have a cloud at 20,000 feet, it's made of ice crystals. That's in this part of the world. It's cold at 20,000 feet, no matter where you are at the time of year. And so, even though they're shallower clouds, these elevated convection, they have more ice crystals in them. And I think that is what allows even shallow elevated convection sometimes to produce extensive lightning. Now, what we have now, we have clouds that are probably taller and deeper and more impressive, as they say, literally more impressive visually and meteorologically. They may be based around 1,000 or 2,000 feet, so pretty close to the surface. They may go up to 15,000 or 20,000 feet. But the problem is here, we have a cloud now that the top of the cloud is not that much above the base of a cloud during elevated convection. And right now, this is a fairly warm air mass, at least initially over LA County. As we saw, with those surface dew points near 60 degrees, it just might not be cold enough to develop that charge separation for significant lightning. Even though these are thunderstorm-like clouds, the top of them is not getting cold enough. Now, this may, again, be why we are seeing lightning in those same clouds behind the cold front, because it is literally colder. It's a few degrees colder surface, and it's more than a few degrees colder at the top of the atmosphere. So I think what we're seeing is that even though the more impressive storm is not producing lightning right now, behind the front, you see that colder air aloft, you see more potential for charge separation, you maybe see more lightning there. So that's my lightning discussion for today. Just a reminder that there was, at least until a few minutes ago, a severe thunderstorm watch in effect for Southern California, including LA County, for the first time in 17 years. And actually, let me see if that's been extended. I don't know if it has been. I'm going to be clicking off screen. I don't think you'll see what I'm seeing for a moment while I do this, but I'll keep talking, trying to see exactly what's going on with that Severe Thunderstorm Watch. There is also a severe thunderstorm warning in effect, again, for western LA Metro, as well as a flash flood warning currently for sorry, that wasn't the audio cutting out, that was my brain cutting out briefly, trying to do too many things at once. Just taking a look to see if that in fact was extended by the Storm Prediction Center or not. Okay, now we have that severe thunderstorm warning, which was expanded across the northern part of LA County. This now includes everything from around the 10 freeway northward, so this includes downtown LA. This includes 3 million people, so a lot of people's cell phones probably just went off. And again, this is a warning for wind gusts of up to 60 miles an hour and maybe even an isolated tornadic spin-up. They would happen too quickly probably to issue a localized tornado warning, so they're just issuing a severe thunderstorm warning for much of LA with a tornado possible tag, because it's a little bit too difficult to pinpoint it with a band like this. Trying to see if the Storm Prediction Center did extend this, and I bet you somebody's already commenting about that answer. Let's just see if there's anything active. Well, this was extended originally through 9 a.m. and it looks like it might still be in effect, which would mean that it would have been, extended again. And I'm just trying to double check this here. Also, with the most recent update from the Storm Prediction Center for their forecast for the day, for again, shallow and low top convective showers. Again, they're calling them showers because not all of them have lightning. Relatively low convective potential energy, but some higher wind gusts. So I think the watch may be expiring, but there's still that chance of tornadic spin-ups. All right, continuing to go through the comments here. Yeah, thanks for sharing, and it still feels silly to say, but the likes do count. The algorithm likes the likes, and it helps spread the word in the channel. We're right around 15,000 channel subscribers now, so this would be a nice day to go past that benchmark. Maybe it'll happen. We'll see. And it is, conveniently, the easiest way to be notified of these pop-up live streams when they occur on short notice, like this morning's, which I only scheduled about 45 minutes before starting. If you subscribe and then turn notifications on, is the key second step to get those automatic notifications. Question, is the tornado risk for LA OC more so along the coast? I think so. It's mainly not necessarily just the immediate coast, but maybe the immediate coast and then 5 to 10 miles inland. So that's really where the LA tornado alley is, such as there is one. Comment from Eric. I think this is regarding the Severe Thunderstorm Watch, which maybe was extended again until 9 a.m. There is, and maybe I'll pull this up in the background since I can go to the Weather West blog. There's apparently an interesting photograph right now of the storm moving through LA now. Yeah, I'll pull that up. I'll show that live in a minute, since that is an interesting cloud. It might be a shelf cloud. So I'll share that screen in a minute. Okay, I'm going to go back and share the screen again. Go back to radar first, just do a quick little update. Yeah, so here's that extended severe thunderstorm warning in the box that affecting 3 million people. There's not really any hail with this. It's not that kind of day, but there are strong gusty winds and maybe even an isolated tornado. But the thing that more people are going to notice is widespread heavy to locally torrential rainfall. And again, this is going to potentially be a problem, the Eaton Fire burn area, and then there's also some heavy rain redeveloping over the Bridge Fire burn area as well. So more moderate sustained rains now over the Palisades burn area that could keep any debris flows or existing flooding going. And then, but right now, the big concern is that higher rain rates that are redeveloping as they move across LA into the Eaton Fire and the Bridge Fire burn areas over here. The severe thunderstorm warning, again, this is one of those weird things that happens in California where there's a severe thunderstorm warning even though there's no lightning associated with this particular cluster of clouds and rain. They do that because these are thunderstorm-like clouds that just, because of some California peculiarities I've been talking about earlier, aren't currently producing lightning, but they are producing severe thunderstorm-like effects, so they issue the warning anyway. Zooming in a bit, you can see that this line does now appear to be intensifying again as it moves through northern half of LA. So it's moving right now into downtown LA and then right along the major freeways. Are about all of them are getting into it. It's the middle of the commute now, so I'm sure it's already a mess out there. It might get worse. Keeping an eye. This is kind of why I'm staying on the live stream right now. I'm kind of keeping an eye on what's going to happen in this region as this moves into the Eaton Fire burn area near Altadena. So that's kind of what I'm staying online to see what happens over the next 15 or 20 minutes there. Double check the rotation and see if there's any. Not really seeing any conspicuous rotations, so there's no obvious threat of a water spout or tornado right now, but I think the idea is these could spin up on pretty low notice in the current environment, hence the warning. Here is the Weather West comment section. Here is that photo I think folks were talking about from Torrance. Yeah, I think this probably is some sort of shelf cloud. You can kind of see the distinct shelf. It might also be a bit of an Arcus cloud. So you can kind of see there's a little bit of an arc here. Classic Weather West photo, by the way. Great cloud with some power lines in it. That's a bit of an inside joke for the blog insiders. What this is indicative of, though, is that essentially the storm is coming in this direction, so toward the camera viewer, and that's an indication of a pretty distinct boundary in the atmosphere. So again, indicative of that incoming squall line, maybe a little bit of intensification as well. Looking again at the satellite here, let's take a look at the water vapor imagery. That actually is not a very interesting view. Shortwave, that's also not that interesting. And you can, okay, so this is essentially a coldness of the cloud tops. As you can see, they're not very impressive offshore, but they cool and condense and intensify right as they make it to the coast. That's this pattern we're seeing. You can also see these colder cloud tops over by the central coast. These are associated with deeper actual thunderstorms producing real lightning that are going to move east and southeast later today. So I am guessing, by the way, that this line, this intensifying line, is what that shelf cloud was, what that was representing. So I'm trying to remember. This is looking west toward Redondo Beach. So I don't know the exact from. Torrance in the username. So this is. So I was a little bit off. So if that's looking west from Torrance from 15 or 20 minutes ago, Torrance is here. And then looking west, of course, is out toward the ocean. So that's actually this line, this leading edge here, as it was offshore. So since then, it's moved inland. It's probably starting to rain now in Torrance. So that's exactly as we hypothesized from the photo. You can kind of see that arc progressively moving in this direction, and that's exactly what that photo showed. So that's kind of cool. There might be some similarly cool views right now if you're in Glendale, La Cañada, Arcadia, looking west as well toward the ocean. Let's take a look again a little bit farther west of the radar near Vandenberg, where there has been, those are some pretty intense looking cells again moving back into the Santa Barbara County coast. Look at that. Let's take a look at the rotation, because I wouldn't be surprised. There's still not much rotation, but it's a strong cell. These are occasionally producing lightning, as I mentioned. And these could once again produce some issues over burn areas as they move eastward later today. By the way, what is going on elsewhere in California? If we go to San Francisco, You can see the low pressure system perfectly actually on radar, which is a little bit unusual. Where's the low? It's here. You can see the flow around the low like this. But lo and behold, it's sunny right now in this part of the Bay Area. But there are some heavy showers near the center of the low off the Monterey County coast. There's some developing scattered showers over the San Joaquin Valley. And then there is this wraparound moisture up in this region, as I mentioned, that over the higher Sierra is producing some snow, some significant snow. So we have this wraparound moisture that's going to bring some stratiform rain up here, so flat cloud rain, and then some puffier cloud rain, so convective showers, isolated thunderstorms down here. It's bringing some significant snowfall to the Sierra Nevada. And if I go up to Sacramento radar and see what that looks like, again, nothing too impressive. So it's actually weaker as you get closer to it, which is always a sign of not very impressive precipitation. But look at the San Joaquin Valley radar. This is a pretty good slug of moisture, and there may even be some localized flooding in the southern Sierra foothills. This is turning into heavy snow at the highest elevations as well. But the main story continues to be, as has been the focus all morning, the LA area. Let's actually take a look at the KSOX radar now that we're getting closer to LA. Sometimes this gives a better view, and lo and behold, I think this is giving us a better view of this squall line that's moving across the LA Basin right now. What do I mean by squall line? Well, look at this very distinct feature, the very clear leading edge here. And what we can see is that it's not extremely intense, but it's intense enough to potentially cause some flash flood problems. And it does appear to be intensifying as it moves across the LA Basin. Take a look at the rotational signature from radar here. So there's actually a little bit more interesting to see on this here. So you can kind of look interestingly right as this line is moving over central LA. Remember what we mentioned about the topographic features? There is a little bit of a weak rotational couplet in that region, north and east of Inglewood. And there's also, you can see the really clear wind shift along the front. So if I freeze this here, you can see that there is this really distinct line where it goes from red to green. That's showing essentially where the frontal wind shift is. And it's showing that there's some pretty strong winds right behind the front. So this is why that severe thunderstorm warning is in effect. And there are a couple of regions of weak rotation. Still nothing that seems particularly indicative of an imminent tornado, but it is indicative that this line has multiple rotating segments on it, which is interesting. Nothing too dramatic, but it is nonetheless the kind of situation where something could rapidly spin up locally. Yeah, and this line is intensifying right now as it's moving over Torrance. This little interesting feature about to move through Huntington Park and Downey and points east. That intensified pretty quickly, and I think this is that pocket of instability right over LA County that I mentioned. So all of this now moving. Unfortunately, this line is intensifying right as it's about to move through the Eaton Fire burn area, which is over here. So this is just 10 or 15 minutes out at this point. More moderate rain over the Palisades burn area now. And I'm going to go back to sharing, or not sharing, my screen so that folks can actually stay up to date here. And I'm going to take a look at a couple of things as I do so, looking for a couple of updates. Just to make sure I'm staying up to date here. All right, so some comments. Take a look at the comments here again. There's a comment from Mary that the Sierra Madre fire cam does show some flow in the debris flow basin, though nothing disastrous. It is worth noting, though, that the torrential downpour hasn't yet moved through, so if there's already some activity before that happens, it could escalate. I might actually go pull that up. If somebody could share a link for me to the Sierra Madre debris flow basin camera, I could Google it, but who wants to waste time watching me Google things? So if you post a link in the chat, I'll start sharing it, since it's about to move through, so it's about time to start looking. Yeah, folks are mentioning there was a particularly intense severe thunderstorm-related downburst of wind in Tempe, Arizona yesterday. There were some really remarkable severe thunderstorms this week in Arizona. This particular microburst, it might have been a microburst, probably was a microburst, straight line wind damage as opposed to tornado, but this one produced some really severe-looking damage. I would not be surprised if there were some wind gusts up around 100 miles an hour, at least isolated in Tempe yesterday. So it was pretty intense. That was associated with the tropical storm remnants, by the way. Severe weather outbreaks in autumn in Arizona and the Southwest do occur. You get that cooler air aloft, you get that jet streak. Remember I was talking about jet streaks earlier. There was also one over Arizona yesterday, along with that deep tropical moisture. That's a severe thunderstorm environment if I've ever seen one. So yeah, I'm glancing at the radar myself again, and that line is intensifying right before moving through the Eaton Fire area. So if someone does share that link to the debris flow basin cameras near the Altadena or debris flow basins in that general vicinity, I'll take a quick look and maybe share them, since I think it might be worth taking a look at as this line moves through imminently. And by imminently, I do mean in the next 10 minutes or so at this point. All right, the link is coming through, so I'm going to open it once I get it. And I do wonder, maybe it might be stripping links. That might be a spam thing. So let me okay, it's worth quickly Googling so I can pull that up. Oh, it's just part of the Alert California network. All right. So that's relatively easy to find. So yeah, I see what folks are saying. There's a minor debris flow at the moment. So I'll pull that up in a couple of minutes here. Yeah, and then there's the Bailey Canyon debris flow basin. So both of them have really small debris flows ongoing right now, from what I can see. I'll share those in a minute. So let me I'll duplicate that so we can get both of them open at once. Got to zoom in a bit. There we go. There's the other one. Okay. And then one more. Got to duplicate that one more time, because that's just the first iteration of the basin. I want the second one. Okay, there we go. I think I have all of them open now. Oh, there's a second one for Sierra Madre. Okay. So yeah, folks, you can't send links live, I guess. Only I can. I think that's probably for all of our protection when it comes to spam and things we don't want to see. Okay, so I'm going to share my screen because there's a few things of interest now, and we're going to see maybe one more round of what's going on. Okay, so radar first. Let's take a look. That severe thunderstorm warning without any lightning, again, ironically, remains in effect. What we do have is the squall line moving through. It's about to move through the Eaton burn area. Again, we're already getting some minor debris flows up here, so this could accelerate them. So we'll watch that as it moves, potentially intensifying. Zooming out a little bit, you can see that leading edge of that squall line is pretty distinct as it goes well to the south. If I do go down to San Diego radar, by the way, let's see what that looks like. It's less impressive at the moment. So I'll go back to, here's the LA radar, which may or may not be the best view for the Eaton Fire. So I'll go to back to the Santa Monica Mountains. All right, so that's the radar view. Here are the debris flow basins. So this one is the Sierra Madre Basin view. If I play these, I'll just play an animation. You can see it's just kind of upper left here. There's some inflow, but it's nothing all that dramatic yet. This is the same basin, different angle. Here, though, I'm going to refresh this. Here is the last 10 minutes over in the canyon, and there's a fair amount of flow coming out. Nothing catastrophic, nothing outside the channel, but it's a significant amount of water now. So that is a debris flow but this is being captured by the debris flow basin. You can see that a bit better, I think, in this other alternate camera view. Now go up on the upper left of your screen. You can see there's a concrete dam there that is intended to capture a lot of the physical sediment. So there is an ongoing debris flow. It's not as big as the ones we saw earlier in the year, but it is remains to be seen how big that gets once the squall line moves through in a few minutes. So we'll take a look at the radar one more time as this moves through. It looks like that's moving right through downtown LA right now with the heavy downpours. And again, just to keep in mind, the Eaton Fire burn area is essentially up here. That's not the exact outline, but just for perspective. And this dry slot is now filling in with the squall line moving now through Glendale, so it's now getting awfully close. It's past Burbank, between Burbank and Altadena. Just kind of waiting to see at this point whether there is any further intensification or what this looks like when it moves through in just a few minutes. This last radar update was 10:44, so that is right now. So this really is live and up to the moment. As you can see, this line is intensifying a little bit as it moves eastward, particularly that segment that just went through just east of downtown LA. And then all this is going to move right into the upslope region near Altadena. So I'm going to go over, you can see me full screen again. Take a look at the questions once again. By the way, this was the first issuance of a severe thunderstorm watch that occurred in the overnight hours last night for coastal Southern California, I believe in 17 years. Not the first severe thunderstorm watch for California in that long. We've seen others. And that's partly a function. It's also not the first time we've seen severe convective weather or even tornado risk in Southern California, even in the past couple of years. It just means that in other cases, the risk was not widespread or obvious enough for the Storm Prediction Center to issue that watch as they did today. So it is a notable event. There was a question about the software I've been using, Radar Scope. That's the live radar imagery. Maybe I'll actually go back to sharing it so I can at least have it on the screen while I'm talking about it. Again, this is the live view as we wait for, let me just draw, again, the general Eaton Fire region here as the squall line prepares to move through. This is data that is coming, again, from the National Weather Service. This is publicly available data. Unfortunately, the Weather Service has been, for political reasons, over decades, this is not something new, been constrained and prevented from making a highly accessible application to portray some of this live real-time data in the way that I would like. They have some ways to look on weather.gov at the radar, but it's really still, honestly, unfortunately, pretty clunky and not very user-friendly. Radar Scope does a great job. It's just an app that takes this publicly available weather radar data from each of the individual ground radar stations all around the country and makes them available in real time and, critically, at very high resolution. So it's not always easy to process the data that's required for each of these thousands and thousands of individual pixels for every radar site in essentially near real time. Sometimes the latency is a matter of seconds between when the radar does a sweep and when it gets uploaded to Radar Scope app. It's the only weather app I still have on my phone or my computer, which is what you're seeing right now, because it is it's simple, but it's done well. It's sort of a unitasker. It's just radar, essentially. There's no forecast, there's no anything else. But if you want that radar information, it's a great resource. You can also, through a paid subscription, you also get access to lightning data. And that's actually helpful from a safety perspective. It really does help you know, is that big dark cloud actually producing lightning or not, if I'm going to be outdoors? And also, where is it going? And that is data that is difficult to get. That is proprietary data that does not come from the National Weather Service. That comes from, I believe that's from a commercial provider known as Vaisala. And their lightning data is hard to come by. You cannot get it on the Weather Service website. Unfortunately, it's not something that the U.S. invested in a publicly available lightning data repository. And so you do have to pay for access. There is no free way to get that information. Radar Scope, with a paid subscription, does offer access, and you can sort of see those lightning strikes imposed over the radar reflectivity, which is what I'm showing now, which means that because you don't see any lightning strike icons, it means there isn't currently any cloud ground lightning here. There could be, and this line is intensifying. This is why I'm staying on, as I mentioned, because this squall line here, let me pause this map. This is actually intensified noticeably just as I've been talking on screen. So take a look. I'm leaving that on as I reanimate it. And look how this line has intensified considerably as it's about to move through the Eaton Fire burn area, which is, again, something we knew could happen but isn't the best thing to be seeing right now. So now I slightly underestimated the time, a little more than 10 to 15 from when I originally said it, but now I do think it's less than 10 minutes out. If I zoom out a little bit as we wait, that severe thunderstorm warning is still in effect for much of LA. Flash flood warning in effect for the Palisades burn area, where moderate to locally heavy rain continues. And again, I would expect the Weather Service probably will issue a flash flood warning in the next few minutes for the Eaton Fire burn scar. And then later on, I don't know exactly where the bridge fire was on this map, but may end up issuing one later on as this squall line moves eastward for the bridge fire burn scar region as well. Let's take a look at the rotational signatures, see what there is to see. Let's see here. Still not seeing anything particularly dramatic rotationally, so I'll turn that off. We may not see any tornadoes today. You know, there's a chance. There was a chance. There remains a chance, but the focus has always really been in terms of risk on the flash flood risk, and that does appear to be quite high still, and definitely not over yet. In fact, the highest risk of flash flooding and maybe the highest risk area near Altadena is going to occur just in the next few minutes here, as this squall line is now almost in Pasadena. Let's take a look at the LA radar, see if it gives a slightly different view on this. Same general idea, but a slightly different perspective. And again, you can see the intensification of this as it moves toward Altadena. I still like the Santa Ana Mountains radar for this better. Seeing now some redder pixels. Again, that's very heavy, maybe even torrential downpours right in the region that we're concerned about, that debris flow risk here. So just a couple minutes away, and this is relatively slow moving, and that is part of the problem here, is that this is not a super fast moving band. You can see that the horizontal trend for it to move across LA Basin, and so it'll also take a while to move across the burn area as well. So I'm going to leave this general drawing on here. Well, actually, I think I want to zoom in some more before I do that. Okay, so I'm going to quick go over, you're going to see my face again. I'm going to look at questions as this continues to roll in. Keith asks, why is there a severe thunderstorm warning, but there is no lightning? I did actually talk about this a bit earlier in the stream, but briefly for re-emphasis, this is essentially because these are thunderstorm-like clouds that, but for a peculiarity in California's weather pattern right now, is not generating lightning. But these are thunderstorm-like clouds, so they issue a severe thunderstorm warning if severe thunderstorm-like impacts are expected from a thunderstorm-like cloud, even if the cloud, in this case, isn't currently producing active lightning. It could begin producing lightning at any time. The more important thing is there is a risk of strong gusty winds, potentially damaging wind gusts, and maybe even an isolated tornado, although I don't see any immediate indication of that tornado activity right now. I'm just taking a quick look at the debris flow basin, since somebody mentioned there was a heavier flow beginning, and it is noticeable, although I think it's about similar to what it was a couple minutes ago, since that heavy rain hasn't yet moved through. So it looks like the Weather Service did just issue, as I expected that they would, a flash flood warning. And actually, this one was for a more widespread area. This includes the Eaton Fire burn area now, but it's actually for the entire region of the mountains here, all the way from Santa Clarita eastward to Glendora. So this is a broad, I'll show that in a minute. This is a broad flash flood warning due to rainfall rates. Even though these are not extremely impressive reflectivity values, I'll start sharing again, actually, because this is worth sharing on screen. Okay, so we're back at radar now. Again, so the Weather Service has just issued two things. They've issued a new severe thunderstorm warning for the squall line. Again, it's another severe thunderstorm warning without lightning, as mentioned, once again, for wind gusts up to 60 miles an hour and still an isolated tornadic spin-up possible. But the bigger risk, I think, is the flash flood risk. This is issued for the next 3 hours, so this isn't going to expire. It's almost 10 a.m. Pacific time, so at 1 p.m. Pacific time. So I bring this up. Flash flood warning for Los Angeles. Radar indicated rates half an inch to 1.2 inches per hour. Even half an inch per hour is very heavy rain, but over an inch per hour is torrential, and that is something that could definitely produce debris flows and flash flooding. The flash flood warning, according to the text, is for flash flooding, mainly for rock slides, mudslides, and possible debris flows on area burn scars, and a small stream urban flooding as well. So again, as I expected, they did just issue that flash flood warning, but although they did not issue it narrowly for the burn area, they issued it broadly. So again, there might be some phones going off. This flash flood warning looks like it affects, let's see, this is actually not going to say how many people in this one, but in any case, so here is that squall line again. If I bring up my nifty drawing tool, still hasn't yet moved into the primary debris flow risk region, but it is now just 2 or 3 minutes away from doing so. So I'll stay on and see what happens. Moderate to heavy rain also falling right now, again, in the Palisades burn area. But this squall line really did pick up in intensity a bit right as it is about to move through, once again, the burn area right here. I'll zoom out once again, look at the big picture. The big picture is nice and rainy. Go west again to the Vandenberg Air Force Base. See those convective bands still moving across Santa Barbara County here. Let's go back to the Los Angeles radar, see what we can see. It gives us a similar picture. Still think the Santa Monica Mountains are the best one here. That's San Diego. That was an errant click. Okay. All right, so if I'm not mistaken, they didn't spend as much time in the valley, but I think that's the 210 freeway. So this is just about, it's just crossing the 210, I think, right now. I know LA folks will get very angry with me if I got the freeway wrong. But this is that squall line of interest, again, once again, right through here. It's now moving through Pasadena. And the rain is now filling in the debris flow risk region here. So let's go over, look at the debris flow basins again, refresh these, see what's going on with the inflows. Does look like the outflow from this basin is increasing. So let's look at the last 10 minutes. That's a pretty robust flow. That's still within the channel, but we're seeing more activity here. Here's the inflow into the basin itself. Make sure I refresh here. There is a little bit of increase in activity. It's interesting to watch this erosion along the channel bank and that accumulation of sediment. They have to dig these out after each storm with heavy machinery, by the way. So just watching again for this squall line to move into that blue oval region here, which is where the highest risk of debris flows probably is in the near future. Again, this is really, unfortunately, the most intense part of this squall line is right aligned with what's about to move through here. And there is a broad flash flood warning in effect for all of the transverse ranges and the inland valleys, so the San Fernando and the San Gabriel Valley, although the flash flood risk is definitely highest in the mountains and near the recent debris flow regions. See me again for a moment while I take a look at the questions that are in here. Hello to the new visitors today. A reminder that these sessions are recorded, so if you feel like you missed something, and there was a lot of hopefully good science earlier in the session, you can always go back and review it. That might only be possible once I end the stream and then it uploads, but all of these are recorded. And you can make an auto transcript, by the way. I know this is going to turn into about a 3-hour live stream before all is said and done, which most folks don't have time to listen through, but you can look at the written auto transcript, which is doing a very good job at transcribing what I'm saying. It takes a lot less time to read what I'm saying, especially with all the gaps, than it would to watch it. So by all means, if you're inclined, you can rewatch a 3-hour live stream, but also that makes it easier to pick out some of the more salient points, especially if you're a journalist or someone else who's looking for direct quotes or particular pieces of information for specific regions. By the way, I'll share it again because there's been enough comments that that it might have gotten lost in the noise. I just pinned this comment, but if you haven't already completed it this year, I do have a survey regarding my weather and climate communications activity that I've developed as part of my University of California role. It is now pinned to the top of the chat. So if you haven't already done it this year, if you've already done it this year, no need to do it again, thank you. But if you haven't yet, please do consider filling it out. It will take you less than 5 minutes in most cases. It's all multiple choice. Just helps us make sure we're reaching who we want to reach with sessions like this one. So again, that's just the pinned link that begins with ucanr.co up at the top of the chat. Thought I'd reshare that again in a quieter moment. Thanks for the kind words, folks. And it's always fun when new people, find out about the Weather West channel during active weather events. For those who are newcomers, when there is active weather, I will be talking about it in California and occasionally elsewhere. I'm a weather and climate scientist, so wear a couple of different hats. Increasingly also these days, someone who studies wildfire and wildfire behavior as well. So yet another awkward hat. But when there are active weather events, active fire events, I'll be here live when I can. And when there are not active weather events, I'm talking about the big picture, about climate and wildfire and weather and Earth system science in general, with occasional updates on what the federal government is doing with respect to all of these things. But mostly, stick to the weather and stick to the climate. And as others have mentioned, it is sometimes, if you want to be notified that when these streams go live or when they're scheduled, the easiest thing that I can recommend is to subscribe to the channel and turn notifications on. There are 2 steps there. I know a lot of folks did the first thing and not the second thing and then wonder, where the heck are the notifications? Well, that's why. You got to actively turn them on. I'm just glancing over at the basins just to see if there's anything new or interesting going on, since I think we're right in that moment where the flows are going to pick up quite a bit, and indeed it's starting to look like they are. So I'll share again on screen in a couple minutes once there's something new to share. Yeah, they're gradually picking up. Nothing dramatic yet. A reminder, folks, that the channel sponsor is Reask, a company that's helping to rethink extreme weather risk in a warming world. I was just having conversations with the Reask team while I was traveling a couple weeks ago. Met with the team in London, and we were talking a lot about wildfire modeling and also severe convective storm modeling, which is partly what we're talking about today, because this is an unusual severe convective day in Southern California with the first severe thunderstorm watch in 17 years. Not the first severe thunderstorm warning, and maybe this is a nice quieter moment to emphasize what is the difference. A severe thunderstorm watch, just like any severe weather watch in the United States, means that severe weather of some kind, whether it's a flash flood watch or a fire weather watch or a severe thunderstorm watch or a tornado watch or a hurricane watch, among others, means that said condition is possible within the next couple of days within the watch area. It does not mean that it is imminent necessarily, but it's a be on the lookout. The Weather Service has in fact used two cooking or baking related analogies to describe the difference between a watch and a warning. A watch, in all cases, is like having the ingredients for something that you're trying to bake or cook out on the counter, the raw ingredients, not assembled, not cooked yet, but getting ready to. The ingredients are in place, but a cake is not a cake if you have flour and eggs and sugar just sitting on the counter. The potential is there if you take the right action to finish the job, but it's not magically going to happen on its own. That's when the watches are issued, is when the ingredients are in place and where the potential is for them to come together to produce the hazard in question, the flood, the hurricane, the severe thunderstorm. A warning, on the other hand, means that either the cake, the figurative cake, is about to come out of the oven, or it has already come out of the oven and it is cooling on the counter. So the cake is now imminent or occurring. So this news outlets often publish this wrong. It's actually a really important thing to get right. Headlines will say flash flood warning for wherever, but perhaps it's a watch, meaning that there is not in fact a flash flood ongoing, but there could be in the near future. Or the reverse is true. Flash flood watch will be the headline, when in fact there is a warning, meaning that you need to take imminent action to avoid being affected by it. So it is actually really important to get this right. And I realize that for some folks it may not be intuitive, but the standard terminology is very consistent. It's unambiguous from the Weather Service. A watch means that the said hazard is possible in the near future in a general region, and a warning means that said hazard is now occurring or imminent within a matter of essentially minutes, or hours in a few cases for a certain kind of warnings, but generally less than a day, in a specific location. So where you are in that warning location. If there's a warning, it means that the Weather Service thinks that said hazard is either occurring in that moment or might be imminent. So to get to my original point about the Severe Thunderstorm Watch, this is the first in 17 years. There have been plenty of severe thunderstorm warnings in Southern California. In fact, I think we've seen them every winter for the past 5 or 10 years. But those are short-fused warnings for localized areas, meaning that something is imminent or occurring. The watch means that the NOAA Storm Prediction Center, the branch of NOAA that is tasked with severe thunderstorm prediction and incidentally fire weather prediction, specifically, which is based in Norman, Oklahoma, in Tornado Alley, specifically foresaw in coordination with the local office in Oxnard that there was a fairly conspicuous pattern that could produce a risk of fairly widespread severe thunderstorm activity. So that means that more than just on a localized basis, that a more widespread outbreak was possible. So far, we're not seeing too much in the way of dramatic severe thunderstorms. There were some severe wind gusts overnight along the central coast. There was a tornado warning, though no confirmed or observed tornado to my knowledge. And so that's an indication that, again, the watch was converted to a warning last night in the form of a tornado warning for Morro Bay. And right now, as a severe thunderstorm warning, meaning imminent possibility of those kind of conditions, those gusty winds and maybe an isolated brief tornadic spin-up for the LA Basin. Those warnings have been issued in the recent past for LA, that's not new. But the watch, again, from the Storm Prediction Center in Norman, for that large-scale pattern conducive to these conditions, hasn't been issued in over 15 years. So that's notable. There is, what the latest comment points out, there is an additional category to watch versus warning. different threshold of designation. So the most common ones are watches versus warnings, as described. Watch is a be on the lookout. A warning is take action because the thing is imminent now. There's also a lesser one, which is called an advisory. It doesn't necessarily mean that it's unimportant, but it means it is a hazard that is less likely to threaten life and property. So, for example, a wind advisory is a lesser iteration of a high wind warning. So wind advisory means disruptive but probably not very damaging winds. High wind warning means could produce actual substantive structural damage and potentially be life-threatening or limb-threatening. A flood advisory means that flooding is likely, but it will likely not be widespread or severe. A flood warning means the flooding is likely and it will likely be more significant in its impact or magnitude. And then for certain kinds of hazards, I believe this is mainly only issued for flash flooding or tornadoes. There may be a couple of other hazards, but this is usually something you're only going to see for flash floods in California. But you can see it for other hazards elsewhere in the country, is an emergency level designation. So the Weather Service can issue an ordinary flash flood warning, which is what is currently issued for parts of LA County. It means that flash flooding is expected to begin shortly or is already imminent, as we've been talking about. But they can also issue a flash flood emergency, which means that not only is flash flooding already occurring or imminent, but it is expected to be of such significant severity that it is something that is well outside of the recently observed range and could go on to produce flooding of a magnitude that would immediately be life-threatening or is well outside the magnitude of what has been observed in years. So that is an elevated warning. That is what was issued, for example, during the Texas floods this year. Numerous flash flood emergencies issued during Hurricane Helene. So this is not common knowledge. So I stuck with the basics, watch versus warning, because that's the most important differentiation. But there are additional ones. Advisory being sort of a lesser version, if you will, of a warning, and an emergency being an even further upgraded version of a warning. We currently don't have any emergency alerts as such in effect right now. Question from Wolfpack9958. It's been 17 years since the last Severe Thunderstorm Watch, specifically in coastal Southern California. So there have been others in the last 15 years elsewhere in the state. How about a tornado watch? Has Southern California ever been issued in a tornado watch? There have definitely been tornado watches for portions of California, and I believe as well for coastal Southern California. So I actually don't know the last time. Someone might be able to dig that up. I don't have the stats in front of me. Definitely in other parts of California, and I believe also in coastal Southern California. But it's been a while. That's for sure. So I want to bring the screen share back up. Here's the radar. As you can see, as I was just talking here, this squall line has now moved through the Eaton Fire burn area here. So that line has just moved through and is now potentially moving to the upper reaches of the burn area, with that larger area of heavy rain now developing in the western part of the county where the broader part of the flash flood warning is in effect. So let's look at the debris flow basin cameras, see what they show. This one is still not too dramatic, so let's go over to the larger basin here. Let's play the last 15 minutes here in the upper left. You can see it's raining heavily, and there is an increase in flow, but it's nothing catastrophic. It's well within the channel. So it's looking like this event is probably going to be manageable, at least as of right now. This could change later if there's a more intense burst of precipitation, for example, but if we look at the last 15 minutes here, the flow certainly increased, but it's not even as big as what we saw earlier in the season with some of those debris flows in February and March of this year. So that's relatively good news for now. I don't have specific reports from elsewhere, so I'll have to leave it at that. And I think it's probably time to give this stream a break. But I will say this. As I mentioned earlier, there are still some thunderstorms out west. These could produce problems later. In fact, there's a new special marine warning, again, for the Channel Islands, just off of Santa Barbara. So Sometimes, and this is noted in the paper I talked about at the beginning of the session, it's these little squall lines behind the cold front. The cold front is now here. That can actually produce the highest likelihood of an isolated tornado or two in LA County. So I wouldn't completely rule out the possibility that this line or something causes an increase in the flash flood risk later this morning or afternoon, further east in LA County, or even an isolated, episodic, brief tornadic spin up. All right, one final round of questions and then I'm going to call it. All right, well, thanks for joining, folks. I'm gonna end the stream momentarily, but thanks as always for joining. And if there is something particularly dramatic, I might pop back in again later. Right now, I'm thinking probably not, but if conditions warrant, I'm always keeping an eye on things. So thanks for joining, and stay safe out there. The main risk, again, if you're in or near a recent wildfire burn area, subsequent downpours this afternoon could still cause problems. So be aware. And again, that'll be later in the day for the more eastern burn areas. So the bridge fire, for example, and points east, that could be a threat into the afternoon, well into the afternoon as well. So thanks for joining, and see you all later.